Hi guys, in this video I'll cover the ArrayList data structure. An ArrayList is an abstract data type that represents an ordered sequence of objects. It provides functions such as adding, removing, or getting an element, and a size function that returns the number of elements in the array. Now in C++, an ArrayList is sometimes referred to as vector. That's because C++ provides a vector class that implements the ArrayList abstract data type. An ArrayList encapsulates an array. That means it has two member variables, a primitive array, and an index that refers to the next available position within the array. Initially, the array is fairly small. It has a capacity of 10, for example. Note that when I talk about the array, there are two terms to distinguish: capacity and size. Capacity refers to the length of the array, or the total number of elements that can be stored in the array. The size, on the other hand, is the number of elements that are currently stored in the array. So initially, the array has a capacity of 10, but a size of 0, because no elements are stored in the array yet. As I add elements to the array list, the size of the array list grows. And eventually the size matches the capacity. That's when the array is full. What the array list does then is allocate a new array that has twice the capacity. And then it copies the elements from the existing array to the new array. That means every time the array fills up, the array list doubles the capacity of the array. And that means that an array list is not a fixed size. It can grow indefinitely as we add values to the array list. Let's take a closer look and see how that works. This is pseudocode that expresses the logic of what the add function does. There's one special case which checks if the array is full. This is done here, counting the elements or getting the size of the array and comparing it to the capacity. If this is a match, the array is full and a new array is created of double the capacity. This is done by getting the size of the existing array and then computing size times 2, which creates double the size, then allocating a new array of size times 2, and then copying the elements from the old to the new array, and then assigning the new array to the array instance variable of the ArrayList object. Finally, the element is set to the next available cell in the array, or the next available index, and the index is incremented. So let's see how this works conceptually. I have an ArrayList here. This ArrayList has internally an array which is initially of length 5, so it has a capacity of 5. Then I add 1, which is the initial element at index 0. Internally, this also keeps track of an index. So index is now incremented from 0 to 1, so it points to the next available position. Then I add 5, which goes here. I increment the index, which now is 2, so it points to the third position. Then as I add 8, it comes to the next available spot. Note that at this time, the size of the array list is 3, but the capacity of the array is still 5. Then if I add 2, I add 7, and now the array is full. Note that the array list is not full. The array list has currently a size of 5, but we can always add elements. And if we do add another element, let's say 5, it hits the special case. It notices that the array is full. It has a size of 5. That's computed times 2, 10. A new array is allocated for 10 elements, so the capacity of 10. And then the elements are copied over from the existing array to the new array. So the new array has a size of 5 and a capacity of 10, so it's half full. Then the array instance variable now points to the new array, and then 9 is added to this array. And the whole process continues. Note that when removing an element in an array list, this would leave an empty position, and that's not wanted. So what has to happen here is shifting all the subsequent elements over to the left by 1. So 8 would go into the index where 5 was just deleted, 2 would go where 8 was, 7 where 2 was, and 9 where 7 was, and then 9 would have to be deleted as well. So this is what it looks like after removing 5. Now, what are the advantages? We no longer have a fixed size memory, so it can increase as more values are added. It has a performance of O1 for adding and for getting elements. O1 is because if we scale this up further and further, the copying fades into significance. So it doesn't really have a big impact. That is because we don't just add 10 by 10 by 10, but we double it in size. So if we start out with an array of 10, it becomes 20. If that's full, it's 40. If that's full, 80, 160. So it doubles every time. And we still get the direct access that we can just compute the offset and go directly to a memory location, just like an array. The disadvantages are that when we delete an entry, and that's somewhere in the middle of the array, we have to shift elements because we don't want to leave null values in the middle of the array. So that is ON. The worst case here is deleting the very first element and then having to shift all subsequent values over by 1. And the other disadvantage is that memory size is larger than needed. Think about a pretty bad case when you have an ArrayList of 1,000 elements, and the internal array is 1,000, and now you add one more element. You double the size to 2,000, but you only use 1,001. So there's always some memory that is reserved and allocated for an ArrayList that is not needed. I hope you enjoyed this video. Thank you for watching.